Hi everyone! In this lesson, we're going to learn how to identify significant digits in a number, as well as how to round a number to a specific number of significant digits. Significant digits are digits in a number that are part of a measurement. These digits include all of the certain digits and one digit that's estimated or uncertain. They're also called significant figures. So if you look down here at this example, 31.5 milliliters, the 3, the 1, and the 5 are all significant digits to give us a total of 3 significant digits. Sometimes numbers will contain non-significant digits, and these will be zeros that are in a number that are not part of the measurement, but that hold the decimal in the correct place. For example, this 0 in 420 centimeters is just holding the decimal in the correct place. We really know that there's a decimal right here, even though it's not written. So the 2 in this measurement is the uncertain digit, and the 0 is holding the decimal place. Therefore, it's not a significant digit. In this next example, these two zeros in front of the 420 are just holding this decimal place in the correct place. So they are not considered significant digits. The 0 at the end here is a significant digit. It's the estimated or uncertain digit in this measurement, so it's considered to be significant. Now don't misunderstand. Non-significant digits, like these zeros here and here, play a very important role, but they're just not considered significant because they're not part of the measurement other than to hold that decimal in the correct place. Notice, too, that I can take both of these numbers, write them in scientific notation, and I no longer need the non-significant digits. So I can write 420 as 4.2 times 10 to the second power, and it still means 420 centimeters. Likewise, I can write 0.0420 as 4.20 times 10 to the negative second. And the meaning is still the same, even though I haven't included these non-significant zeros. There are two types of numbers you're going to come across in chemistry: exact numbers and inexact numbers. Now, exact numbers are integers that result from counting objects, and they will have an infinite number of significant digits. So down below here you see 3 ducklings, and we know there are 3 ducklings to an infinite number of significant digits, 3.0000, on and on and on. So we say that this 3 has an infinite number of significant digits. Here again we have 6 paper clips. Those are counted objects. We know this 6 to an infinite number of zeros past the decimal. Of course we don't write them, but we say that the 6 has an infinite number of significant digits. Inexact numbers are measurements that have an estimated digit. So for example, volume measurements or length measurements would be inexact numbers. Based on the units after each of these numbers, see if you can determine which ones are exact and which are inexact. Stop the video, and when you restart it again, I'll have the answers posted. Numbers 1, 3, and 6 are all exact because they all involve counting objects, and all of the other ones are measurements, so they're inexact. These are the rules for determining the number of significant figures in inexact numbers, and these rules are on the back of your periodic table. First rule, all non-zero numbers are significant. So if you see a number like this, you simply count all of the digits in it. There's 6 digits, so there's 6 significant figures. Zeros that are between numbers are significant. So this 0 here in 8,035.2 is considered significant. Therefore, there are 5 total significant digits in that number. Finally, zeros to the right of a number are significant, but only if a decimal is present. So here I've given you a couple of examples. In both 7.0 and 70 with a decimal written, there are 2 significant digits. The 0 is significant in both cases because it's to the right of a number, and there's a decimal written down in that number somewhere. So those zeros are significant. If you look here at the number 70 without the decimal written, that 0 is not significant. It's to the right of a number, but again, there's no decimal present. So in this case, this 0 is holding the decimal place. So it is not considered a significant digit. See if you can determine how many significant figures are in each of the following numbers. So remember, if you've got an exact number, it's got an infinite number of significant digits. And if you have an inexact number, you're going to have to determine if the 0 in that number is significant or not. So stop the video, try the questions, and when you start the video again, I'll go through the answers. Number 7 is an inexact measurement, and it has 4 significant digits. The 0 is not significant because it's to the left of the first number. Number 8 is an inexact measurement. The 0 is not significant because it's to the right of a number, but there's no decimal present, so there are only 3 significant digits here. I'll write these answers down. For number 9, the 0 is significant because it's an inexact measurement. The 0 is to the right of a number and there's a decimal present. So all 4 digits are significant. 4 significant digits. Number 10 is an exact number, so there's an infinite number of significant digits. Number 11 is something we haven't seen before. It's scientific notation, but what you want to do is just focus on the mantissa here. And the cool thing about scientific notation is that every number in this mantissa is going to be significant. The zeros are always significant because no matter where the zeros are always going to be to the right of a number, and there's always going to be a decimal present. So just count the number of digits in the mantissa. There are 5 of them, so there's 5 significant digits. You don't even have to worry about the times 10 to the negative 7th. Okay, try the same thing with questions 12 through 16. So stop the video, try the questions, and when you come back, I'll go through the answers. All right, for number 12, this 0 is not significant because it's to the left of a number. So there's only 3 significant digits here. Number 13, it's an inexact measurement. The zeros are to the left of the first number. They're not significant, so there's only 1 significant digit here. Number 14 is an exact number. Your reams mean you're counting like reams of paper. So there's an infinite number of significant digits there. For number 15, the zeros in the middle here are significant, and the zeros after the 7 are to the right of a number, but there's no decimal present, so you can't count them. So there's a total here of 5 significant digits. For the last one, you have to be careful. This is an exact measurement. We're counting cards, so that would be an infinite number of significant digits. Another important skill is to be able to round to significant digits. We use this a lot in the lab when we take measurements and we put them in our calculator to do a calculation with lab values, and we get a number on our calculator that stretches to the end of the calculator, but we really need to round it appropriately. So I'm going to go through 4 examples to show you how to do this. This first example says is 0.487, and we want to round it to 1 significant digit. So your first job is to find the first significant digit in the number, which is this 4. Remember, the 0 is not significant because it's to the left of a number. So we're going to round this to the 10th place. Next to that 4 is an 8, so we're going to need to round that 0.4 up to 0.5. So that number rounded to 1 significant digit is 0.5. And you might want to stick that 0 in there just so you can see the decimal a little bit more clearly. In this next example, we want to round this value, 19,900, to 2 significant digits. So again, find the first 2 significant digits in this number. That would be the 1 and the 9. So those are the only ones we get to keep, but we still need this to mean 19,000, or in this case, it's going to be 20,000 because we're going to end up rounding this up. So notice that the number next to our last number that we're going to keep is a 9. So we're going to have to round this first 9 up to a 10, which takes this up to a 2. So we're going to end up rounding this to 20,000. The problem is, if we write the 20,000 like this, we don't have 2 significant digits, we only have 1 significant digit. That would be the 2. All the zeros are not significant because they're to the right of a number, but there's no decimal present. And so you could argue, well, let's just put the decimal in. But as soon as we do that, now we have not 1 significant digit, but 5, because that makes all of the zeros significant. So our job is to write 20,000, but with only 2 significant digits. And so the only way to do that is to write it in scientific notation. Write 2.0 times 10 to the 4th. And then you will have 19,900 rounded to 2 significant digits. Okay, at this point, try the last 2 questions on your own. Just stop the video, and when you come back, I'll go through 19 and 20, and you can check your answers. For number 19, the first 3 significant digits in this number are 3, 3, 8. The zeros are not significant because they're to the left of a number. This 8 will be rounded up to a 9 due to the 5 next to it. So the correct answer to this will be 0.0000339. Or another option is just to write it in scientific notation. So keep the 3, and the 9, put in a decimal after the first value, and take it times 10 to the negative 4th. For number 20, we get 1 significant digit. So the first significant digit in this number is the 9. However, that 9, due to the 6 next to it, is going to round up to a 10, which rounds this 0 up to a 1. So this value, rounded to 1 significant digit, is just the number 1. The sooner you get comfortable using these significant digit rules, the better off you'll be, because we're going to use these really till the end of the course. So ask a lot of questions. Just keep asking questions and keep practicing until you feel like you have this under your belt. And you'll be really glad you put in the time early. So good luck.